Alright, welcome back to Advent of Code 2022, day 21. Almost there, almost to the top of the whatever this is. I guess this is kind of, this image is supposed to be like the journey that we're taking with the volcano and the ocean. Yeah, okay. All right, let's begin. Monkey math. Spelled it the American way, of course. The monkeys are back. You're worried they're going to try to steal your stuff again. Oh no. Actually, that was an easy problem, wasn't it? The monkey problem. But it seems like they're just holding their ground and making various monkey noises at you. Eventually, one of the elephants realizes you don't speak monkey and comes over to interpret. As it turns out, they overheard you talking about trying to find the grove. They could show you a shortcut if you answer their riddle. Each monkey is given a job, either to yell a specific number or to yell the result of a math operation. All of the number-yelling monkeys know their number from the start. However, the maths operation monkeys need to wait for two other monkeys to yell a number. And those two other monkeys might also be waiting on other monkeys. Okay. Your job is to work out the number the monkey named Root will yell before the monkeys figure it out themselves. What do you mean before the monkeys figure it out themselves? I didn't understand that last phrase. Okay, fine. So we've got root. So it's a lone number means simply yell that number. And I guess it's divide is always gonna be divisible. What number will the monkey named Root yell? It's just topological sort, isn't it? Oops. Okay. Right then. We just find the number that the monkey yells. Right. We could try calling this recursively. Actually, it should be fine for this size. I can increase the stack limit a bit. Not too much. I don't want to crash my computer. But how much are we talking about? Oh, okay. Yeah, we can deal with that. 2171. All right. So All right. I mean, I could use the eval, but it's actually straightforward to parse this, so I'll actually parse it and do it properly because these are not. Yeah. Okay. So where's root? Okay, it's not at the top. Fine. So we need. Alright, let's make some sort of hash table then. Store all the knowledge. Line in f read lines. Okay, so we want. Alright, so monkey name and num that ELs equals line.strip.split. Let's split on colon space. So that will get us the monkey name. And then we've got this. I reckon we just take that string and put it in the hash map for now. Yeah, okay. Alright, let's fill the hash map out, make sure that actually runs. Okay, now we're going to define get num of a monkey. If this doesn't work recursively, then I'll just use topological sort. So we want to take the string and check if it has 1 or 3 arguments if we're going to split it by spaces. So args equals monkeys monkey dot split. If length args equals 1, we return int of args 0. So otherwise we've got 3 arguments. So if args 1 equal, we'll just do an if condition for each of these. So it's if it's plus return. So then we need to do so num a will be get num of args 0. Num b equals get num of args 2. We could just use eval again. We can just say return eval of... Will this work though? Because we have... Maybe it'll work, I don't know. num_a plus args1 plus num_b. I don't know if you can reference num_a and num_b like that. I don't think you can. You can try. I don't really know how eval works. Print get num root. It's gonna crash probably because I need to. Oh. Okay. That was quick. I thought the recursion limit was like 1,000 or something. So it could go, but it doesn't necessarily go 1,000 deep because. Yeah, okay. Some of these monkeys are not even ever checked, probably. Would that be the answer? I mean, it does lots of multiplications, so it's plausible. Correct. Due to some kind of monkey-elephant-human mistranslation, you seem to have misunderstood a few key details about the riddle. First, you got the wrong job for the monkey named root. Specifically, you got the wrong math operation. The correct operation for monkey root should be equals, which means that it still listens for two numbers, but now checks that the two numbers match. Oh, crap. You need to figure out what number you need to yell so that the root's equality check passes. Oh, man. Interesting. It's kind of like if you could end up with a huge algebraic equation with just one variable missing. And then you'd be able to solve, wouldn't you? Can I really do that in Python? It will always be a scalar times humans number plus another number, integer, wouldn't it? So it's not that complicated. So it's always going to be of the form. Okay, I see a way we can do this. So root. So we will, okay, whatever. We skip root here. Or we'll say it. Root is never referenced, is he? By another monkey. He better not be. No, that wouldn't make sense. I mean, it could be, but it might never actually happen in roots chain. Alright, so... Okay, so we keep the monkeys table as it is, that's fine. Okay, sorry, I should be having the ID up now. Alright, so... Alright, I have an idea. So... That's part 1. I'm surprised... The eval... Well, no, the eval... Yeah, the eval should work. That's doing what it should do. Alright, so... Part 2. So, root... I want to define a new type of number. It's not an integer. It is a tuple. So it's going to be get num of the form a plus b times, what was the name for human? It was homin. Okay. Alright. So... redundant parentheses. I'm returning a tuple. Suppose you don't actually need the parentheses. Okay. Alright, so num a equals get num that, num b equals get num that. Okay, so now we actually do need to override this. So we need to say if args 1 equals so if monkey equals common, we need to just immediately return 0, 1. Okay, and now we just do all the algebra associated with the operations. If it's plus, return wait, divide. I didn't think about divide. Okay. Yeah, no, this doesn't quite work. If I divide these two numbers. I'll just end up with a really horrible fraction. Hello, Ku. Small monkey business, yeah. This one is interesting. I can sort of see how I would do it by hand. Yeah, it's afternoon for me. So if I were to try to keep an algebraic expression, it's not gonna work. Yeah. Because if you try to divide a polynomial by another polynomial, well, I could have. Is there something in Python that handles polynomials? If I keep track of the polynomial until the end, then I'll have an explicit formula for what one needs to be. I mean, the alternative here is to do binary search, but that's not quite right. Because it's a high degree polynomial, so you'd have to search a lot of values. You can't just locate the value from one starting point. Ultimately, we're trying to find the root of a polynomial here, I guess. That's what this is. Alright, let me have a look if Python can keep track of polynomials, because then that's kind of what we want. Well, I could do that in NumPy. I call hacks tree. Hello, bad for beans. Let's have a look at the NumPy thing. I'm okay, bad for beans. This problem looks nice, but it involves polynomials, so I'm trying to find a way to do polynomials in Python without writing my own polynomial class. I don't know what polynomial is. It's like x squared, take away 5x plus 7, something like that. Except we want to store a fraction, a polynomial divided by another polynomial. Trying to figure out if NumPy can. Alright, let's have a look. NumPy. Polynomial fraction. I mean, even if I do this, what do I then do with the result? Maybe let's have another think about this. I'm up to 8th grade at Khan Academy now. Well, I've heard Khan Academy is good. Is it free? Like all that stuff? Totally free. Yeah, it's a good site, I've heard. Maybe I don't need to do this. Let's try something different. We could actually do binary search or some sort of search. So let's look at the example actually. So in this example, they're saying you need to pass 301 to human to get the result. So 301 to human. So human is 5. Change that to 301. This will become 301 minus 3, and so on. And if you do all the calculations, this will end up being 150 and 150, which is what we want. So, okay. I think first of all, we need to what I can actually do is I can fill out all the numbers I do know and just leave the ones which involve human. So I can say, so that actually fills out lots of the monkeys with values. Actually, no. What am I trying to do? Yeah, okay, let's do that. So, okay, let's not get the form. That's a bit difficult. So, if monkey was human, so I want to say if monkey equals human, return. We don't ever get negative numbers, do we? We might. Right, return none. So we want to skip all the ones that derive from human, including, that will include root. So if num A is none or num B is none, return none. So otherwise we just proceed as before. But also we want to set monkey equals, okay, result equals that, result, return result. All right, so now we want to try to get num root. We'll just get a none, but we'll actually fill out lots of monkeys and make the table a bit better. Let's try that. Can't multiply sequence by non-int type tuple. Have I still got tuples in there? Okay. So now I want to see what this table looks like. For I, X in monkeys dot items print ix. So this is what it looks like. We have lots of numbers. Ooh. We should actually int these as well. It's just a bit. I want floats. Most of them are filled out. So this one's that. Got that. Actually, most of them are filled out. That's interesting. I was expecting lots of humans to kind of disrupt. So we can actually... try to... Alright, this is pretty good. So... if we want to try, now that we've filled out a lot of those, it'll be much quicker. So if we want to try, define try, no, don't write try, define, oh, am I not on the ID again? Whoops. All right, so I was just, it's actually filled out most of the monkeys and it's left a few algebraic expressions in. Define attempt. Let's say, given a num, we want to set monkeys. So we want to get, okay, we want to find the nums we want. So args equals monkeys root dot split num 1 equals int args 0 num 2 equals no, these are not ints. Okay. Monkey 1 equals args 0. Monkey 2 equals args 2. We want to reassign human. Equals the num we're going to try, and then we just want to run the thing we did before. Return get num monkey 1 get num monkey 2, and then let's just try this. So let's print attempt 1. This will be interesting. What's going on? Get num. Oh. Just call that get num 2. We want to use get num 1. Yeah. Oh, hang on, what's going on? Monkeys, monkey dot split. Oh, it needs to be string. This needs to be string. So if we try also yeah, okay. We do actually need to keep them as floats. That way we can work out if we've got a round number or something. Man, how are we gonna find out how to make these numbers equal? So, whatever we do here, it's gonna change one of these numbers. 127. Just give it a big number. Well, it's the left number that's changing. It's not a simple case of binary search because this is like a high degree polynomial, so okay, we've got something. Now what? I reckon the original idea I had would actually work with the polynomials. I just don't like the idea of coding it, but I suppose it actually makes sense. I mean, but then I'll end up with a polynomial, and then what? It's easier to root find once I actually know what the polynomial is. If it's a high degree polynomial, we still have to do the same type of root finding algorithm. We can't just... Yeah, but then you can use Newton-Raphson method or something. Not really. Oh, maybe. It's like L'Hopital's rule. I mean, basically, we're trying to make this 0. Okay, let's do that. We're trying to find a value that makes that 0. Okay, I don't know. For I mean, okay, let's test that this works on the example. So we want to do print attempt 32, but at least, no, 301. 0. Okay, so that works. We just need to know what number to insert there. That's the tricky bit. We could just try lots of values up to 1,000,000, see what happens. It's probably going to be a huge number though. The one we want. Right. For I in range. If attempt I equals, let's say it's less than 10. Print I. Okay, they're giving us clues because if you need to divide by something, then that's got to be divisible by that number. So I Alright, it's looking, but it's not going to find anything. I think I should try this polynomial thing then. I guess that's actually a start. Because if you... well, the other thing is, it might actually be a single chain. So if we... Oh, I'm not filtering. Damn it! I forgot to do this. Get to root. Okay, let's try again. Because that's what makes it faster, isn't it? Parts 2. Huh? Oops. Okay. Let's decrease this. Let's give us something. $1,000 should be fine. Yeah, okay, 10,000 works. Alright, so okay, that's how okay, Alright, let's print this table again then. Let's have a look at it. I think we can just kind of work out step by step what humans should be if we backtrack from root. Let's have a look. So, for I be in these dot items, if let's say space in v print iv. Right, this is our table. It's actually quite small. Where's root? Okay. Also, it's minus 23 degrees right now. How's your day? It's nice and sunny where I am. Actually, it's a bit hot in the nighttime. I should have turned my AC up. I got through a huge bottle of water. Alright, I think I can't decide on how to proceed on this, but I have a couple of ideas. We're doing monkeys with typewriters. Kind of. We have monkeys, and they each have numbers. Or either they have a number, or they have a operation of two other monkeys' numbers. And we gotta find, ultimately, the number of the monkey called Root. At least that was part 1. Now part 2 is tricky. there is a monkey called Humn, Humn, which is actually a human, just representing us. We have to choose what number Humn has, which would cause root to have the number we want. So it's just a huge chain of operations. Alright, I have an idea though. Let's have a look at this table. If we were to... Alright, so... If okay, so let's change this a bit. Left equals logs 0 if num a is none, else string of whatever we get num from num a. Right equals the second one. If num a is not, how do you say if not is, if not num a is, how do you actually do this in Python? I think it will allow me to say is not none for comparisons with none. If num a is not none and num b is not none, else monkey equals left logs 1 right packed up again. And return none. Alright, that's hopefully it works. Okay, so it's filled in some numbers. That's interesting. So root looks for SBTM. And SBTM GLGL. So it looks like we've always got one number filled out. Do we ever have two numbers filled out? Well, if it's just one number, if we've only got one unknown always, then we're done. Let's double check that. Now I know how to solve this, but that's because they made it easy. If they had made it with two unknowns, it would be very hard. Alright, so oh, I can actually check this by eye. It's a pretty small table. So far we've got numbers everywhere. Yeah. Okay. Okay. There I was trying to deal with high degree polynomial fractions. Alright, so what we need to do is we need to say how do we okay, I'm just trying to how do we write this? It's gonna be recursive again, of course. I'm gonna say define target of a monkey. No, what am I trying to say? This method will return the value human needs to be in order for monkey to return the value target. No. Just call this solve. I can't think of another name. Solve returns the value human needs to be in order for the specified monkey to return the target number. Okay. So args equals monkey dot split we need to basically solve this equation. So just check all the cases. We need to find okay, let's check all the cases. If args1 equals plus that one's easy. We just do new target equals hang on. Okay, if args 0 dot is digit let's say num equals int args 0, else num equals int args 2. So that gets whatever integer is there, and the new target is going to be the old target minus that extra integer num. And then we want to return solve. Hang on. We can simplify this. New monkey. Okay. If args 0 dot is digit new monkey equals args 2, else new monkey equals. We just want to identify what the new monkey would be. Args 0. Alright, so solve for the new monkey, the new target. Now there's one catch. If monkey equals common, then that is redundant. That's asking us, what does common need to be for common to be target? Well, common needs to be target. Okay, that's the base case. So we've handled plus. We can try running this. It'll crash, but well, but let's just see if we get the error we actually expect. We want args equals monkeys root dot split it's this thing again. If args 0 is digit, monkey equals args 2, target equals args 0, int args 0, else the other way around, monkey equals args 0, target equals int args 2. So ultimately we want this. We want solve monkey target. We're trying to find what common needs to be for this monkey to equal, for this value to equal the other in root. And that should crash. Yeah. So now we need to handle all the different cases. So let's stop printing stuff. just make sure we get the right kind of crash. The monkey. Oh, what have I done here? Well, that's the wrong error. Okay, it doesn't know yet. Fine. Okay. If args1 equals minus, so we need it's digit. So if the first one is the digit, we need solve. So the new monkey will be new monkey. It's always new monkey. The new target will be. So we've got an integer minus monkey. So we want int args 0 minus target. Else we could have simplified this. Let's just say target minus int args 0 . Yeah, that's better. So I'm just trying to write out, okay, that's plus. If the first one's the integer, then we do the target minus that integer. Otherwise, we do the target minus the integer, wherever the integer is. That's how we undo a plus operation. I've just realized there's actually probably a clever way to do this. We could actually just what, is the stream down? Seems like it's still up for me. The vid is frozen. Can you still hear my voice? Or it was just on my end, maybe. I didn't see any indication this time. Alright, so I think there's actually a clever way of solving this. I won't bother doing it. I think what you could actually do is just reverse this. Say don't worry about this. So let's carry on with this. So that is digit. We do Otherwise, we do we want, so args2 is the digit, so it's x minus digit equals target, so we want target plus that number. Okay. Getting there. Now just multiply and divide. So now we've got multiply, that one's easy, I guess. We want so if the first one is the digit, we want target divided by int args 0. Otherwise, we want target divided by int args. I'm going to leave this as a floating point for now. Then divide. Return. So if the number divided by our number, so we want our number, the next monkey should be the integer divided by the target. Just the reverse of the above. Oops. And if the number's on the right hand side, it's the target multiplied by the x. Alright, that actually work. Part 2, that number. And now we can actually check this by print attempt of, okay, result equals solve monkey target. We can actually confirm this works by now plugging it back in. What's wrong here? Oh, because I changed the way the table works. Alright, doesn't matter. That might be the right answer. Something seems strange about it though, I'm not sure. Okay, it looks familiar, like I've seen that number before. Okay. That's it. Actually, that approach that I did at the end there was actually pretty straightforward. I think the problem was I was just assuming a very general case where root is an algebraic expression involving two unknowns, and actually lots of monkeys are algebraic expressions involving two unknowns, in which case it's very complicated because you can't reverse engineer these expressions if they're both unknowns. But they were really nice. They made the problem so that every expression had only one unknown, which means you can reverse engineer every single expression in the normal way. If they had gone down the complicated route, because I was about to write
something with polynomials, which I think would kind of work. But so basically, my idea was human is x, it's an unknown. So you can go through the chain, and every time you do an arithmetic you do some sort of arithmetic operation involving human, it becomes a polynomial. So if you do human times 5, it's 5x, x plus 5, or whatever, and then and then x is multiplied together to get x squared, and so on. Basically, every time you've got one polynomial, either you add them together, you get another polynomial, or you subtract, or you multiply, in which case the degree goes up, and it becomes a higher degree polynomial. Or, and this is what the most problematic one was, if you divide one polynomial by another polynomial, you basically have to create a fraction where you have a polynomial as the numerator and a polynomial as the denominator. And from then on, you have to maintain both the numerator and denominator. So every time you multiply, you have to multiply out the denominator and so on. But you can do that. It's not that hard. You just need to keep maintaining it every step. And then you end up with root being equal to some long-winded polynomial fraction. Once you've got that, you can then find the root using Newton-Raphson method, maybe, because you can use calculus to find the gradient of a polynomial pretty easily. Method. But then you have to use L'Hopital's rule to differentiate or whatever. But I mean, it's a polynomial. As long as it's a polynomial, you can do its calculus is super easy. So Newton-Raphson method is a quick way of finding the root given a differentiable function, and this is a polynomial fraction, so this is definitely differentiable. And this is basically what we did in school. This wasn't even university level stuff. Like, we did Newton-Raphson in school. We learned how to use binary search to find roots of polynomials, and we used Newton-Raphson method to find roots of polynomials. And there was another one. I can't remember what the other one was, but it wasn't very good. Newton-Raphson is the best, really. Newton's method. Interesting, but aren't there just so many methods that could be referred to as Newton's method? Or maybe not, I don't know. I've never heard it referred to as Newton's method. I've always heard Newton-Raphson, but let's see what happens if I search for Newton's method. Okay, yeah, it is referred to as Newton's method as well. It's actually the default name for the wiki. Poor Raphson. Raphson must be spinning in his grave. Oh, and I was so heavily concentrating on all that algebra that I didn't notice that DIJ subscribed 31 minutes ago, so thanks DIJ, thanks a lot. We have 4 more days left of this stuff if you enjoy it, so I'll be back with another problem tomorrow. I was like an hour late today. Frightened Swan, you did this in, yeah, numerical analysis is where it comes up. Numerical analysis, so when I was in school, we had a course in A-level mathematics called numerical methods, but it's basically a watered down, light version of what you do at university, but not using too much algebra and stuff. We did do Taylor series expansions though, so that's kind of complex. But yeah, when I got to university, we basically did it again, but properly. You know, using all the theorems, proving them all that stuff. No cutting corners like we did in school. Some ancient Babylonian who figured it out trillion years before. Yeah, probably. I mean, it's Newton-Raphson is kind of intuitive. So it's just he formalized it basically, or they formalized it. It's just following, using the gradient to choose your next point. But we didn't have to use this. And actually, if we did have to use it, I would be surprised, because that's actually quite a step into the realms of mathematics if we had to use Newton-Raphson. Well, not Newton-Raphson. You can still use binary search and stuff to find roots, and that's actually, computer scientists do know binary search, but it's just quite slow. .99% of time in practice these days, people just use an approximation, perhaps a zero-order approximation of Bayesian. Yeah. Oh yeah, but I guess when you are talking about it formally, you say we use what, the second degree of the Newton-Raphson method or something. I don't know how you normally say it. You normally specify what order, yeah, what order you're using. Using F and F dash, yeah. Cool stuff. Let's have a look at the stats then. I was like, if I had just gone for the easy approach, I would have solved it a lot faster. I was just hung up on what to do with polynomials, so sometimes you just gotta look at the data with your eyes and see what it actually looks like. Have you seen Newton's fractal? I don't know. Is it like the Mandelbrot set or something? I did one course in university on fractals. I didn't really remember anything from it, and I don't think it was even in the exam. It was just kind of an optional course. It was called Geometry and Groups. I mean, I've seen fractals before. I don't know if I've seen this particular one. The interesting property is that in a small area around each point, either the whole area is one color or every single color is in there. I see. Oh. I remember in school we studied the Koch snowflake and we tried to wait, which one's the Koch snowflake? It's the one with infinite perimeter, isn't it? Koch snowflake. Yeah. It's the one where you keep cutting out a third of each edge, so you end up with an infinite perimeter but a finite volume shape. And of course, this was in school, so everyone made a joke about it being a cock snowflake. All right. On that note, I think done. I can have lunch now. I'm gonna have lunch not later than 4 p.m. for a change. No one in your school made that joke. Well, I was in an all boys school. Maybe it was more common in an all boys school. We were 16 when we were told that. Yeah, actually, probably at A level, we didn't really make jokes like that. I think we had matured enough at that point. Just before A level, GCSE, I would say, is when those jokes came out. Because after that, you then are in your specialized sets for your subjects. Before that, everyone's doing every subject and stuff. But A level is the bit where they weed out all the people who are, I don't know, failing their GCSEs. Oh, not many people have solved it yet. Oh, actually, yeah, quite a few people have solved it. Oh, I was looking at day 20. Oh, no, that's right. Hang on. $4,000. Okay, yeah. Alright, and my buddies have solved it as well. Pontoon, who was in chat yesterday, said they were gonna do 19 at the weekend. Alright. I guess today I also probably want to do some Professor Layton. Maybe some oxygen not included as well, because I really want to launch that rocket and get that over and done with before I forget how all my thermodynamics. Alright. Are you planning to work on CG more? Probably after the 25th, because that's when Advent of Code will actually end. Because it's now taking me like several hours a day. Today was short, I guess, but yeah, I think if I can set aside a larger period of time after the 25th, then that would be good. Plus, Silver has yet to unlock, doesn't it? So we actually have quite a bit of time to do stuff. All right, and oh, Silver opened yesterday. Okay. Okay, cool. And thanks again, DIJ, for the subscription.